So let's get started. Good afternoon, ladies and gentlemen. My name is Fu Hualin. I'm the Dean of the Faculty of Law. So welcome to the second edition of the HKU-Mok lecture series in Frontiers of Law. The series was established by the Mok Yu Charitable Foundation, Mo Qingyao Ci San Jijin. We are honored to have Mr. Edwin Mok, son of Dr. Mok Yu, present here today on behalf of the foundation. Mr. Mok is a lawyer himself. So welcome to the faculty, Mr. Mok, and thank you for your support. The Mok family has a long-standing history of supporting the university. The inaugural lecture took place in 2018, but was unfortunately suspended due to COVID. So this is the second lecture with Professor Joanna Bryson as the speaker with the wonderful title, Whose Problem is Superintelligence? Let me briefly introduce Professor Bryson. Joanna Bryson is the academic expert specializing in both natural and artificial intelligence. Her research covers systems engineering of artificial intelligence, as well as autonomy, behavioral ecology, cognition, ethics, cooperation, and technology policy. She holds degrees in psychology from Chicago, Edinburgh, and in AI from Edinburgh and MIT. She also has professional research experiences from Princeton, Oxford, Harvard, and among many others, alongside digital systems engineering experiences in financial and manufacturing sectors. Since 2020, Professor Bryson has been the professor of ethics and technology at the Hattie School of Governance in Berlin. So without further ado, your words are yours. Thank you.
Well, thank you very much for having me. I didn't realize that it was the honor of being the second of the lectures, but thank you very much for your kind welcome and hosting, especially Dr. Mok. But thank you to my host. Benjamin has also been a wonderful host, and Grace. So thank you very much. I will go because I don't know how many of you have watched me on YouTube or something, but as usual, I have a lot of slides. Please do not hesitate to ask a question. If I'm not being clear, I want to know. So please, if it's going to be an argument, I'll say, let's do that at the end. But if it's a question, that's fine. If it's a point of order. All right. So I'm going to try to talk about 5 things to different lengths. First, I'm going to talk about what we're talking about, okay? And not just what is intelligence, but also what does it even mean to mean something, okay? Then I'll go into talking about how intelligence is now, and then I'll talk about superintelligence as a subset of that. And then I'll talk a little bit about governing AI, and I'll focus on the European Union. And then at the end, I'll talk about not focusing on the European Union, thinking about this more generally. Okay, so what does it even mean to mean something? When I was an undergraduate, I totally did not understand the philosophers who said that words mean exactly how they're used. That seems very cyclic. How can that be? It just seemed to me like a non-answer. And yet it turned out in the 1990s, people started actually having the computer ability to check this. And so at the time it was called latent semantic analysis. The idea is you're figuring out semantics, the meaning of the word, by looking at the neighbors of the word and just recording. It's a very simple measure. You're just counting the words on one side or the other side of the word you want to know the meaning of, right? And this is basically the basis of all of the things that you're seeing, all the generative AI. The only difference is that we don't only look at a single word anymore, we look at whole phrases. But for illustration here, I'm going to show you the single words. It's a little easier to draw. It's still hard to draw. But the same technology that people were using to try to test whether Wittgenstein and Quine were right, to try to figure out semantics and to do psychology tests, wound up being really useful for a totally new application that we never had before, which was web search. Okay, how do you find one out of trillions of pages, right? I'm old enough that I remember when there was one page that linked all the other web pages, and you could go to it and you could see all the pages linked there. But of course, that became not very usable after a couple of years. My father complained to me, I went to your page and it made my computer crash. I thought, okay, it's not going to work anymore. Anyway, this is just a quick illustration. So the words we're trying to understand here are scholar, paper, and rock. And then we're looking how often two words, obscure and hat, happen to be next to these words. Okay, so next to doesn't mean immediately next to, it's within a window. And people used in the 90s spent a long time figuring out how big should the window be. But typically it would be within 5 or 7 words of the target. And then you would just have a count. So the words mean different things because hat and obscure occur next to them in some text. So in some big set of data that you've taken from somewhere. You're coming up with these counts. And so the idea is that if the counts are more similar to each other, the words mean more like the same thing. So scholar is more like paper than it's like rock. Okay. So this is, it's kind of crazy because meaning has turned into a cosine. Sorry that you're a law audience, so maybe you don't like to think about cosines, but they're like one of the simplest things in math. It's not a big deal. It's just the distance between angles. I drew here because I can only draw in 2 dimensions, 2 words, but in fact, nowadays we use like 2 million words. So if you can imagine a 2 million dimensional space, then you compress that. You use mathematical compression, which brings out the signal a little bit. And this makes it work more like humans, but that includes some bad things, as we'll show on the next page. Okay, so people who have until recently been the ones who were good at using web search were the ones who sort of got it. They had an intuition about what 2 or 3 words would get them to the page that they were looking for, right? But it turns out that not everybody was good at that, which is part of the reason that the big tech worked so hard trying to find other ways to help people search for web pages. Okay, so this is my most cited paper, so I always feel a little bit obligated to mention it. And it's also kind of illustrative of where we've gone with this. So again, we're still using just single words, but I had the intuition because I was interested in the way words worked and the evolution actually of language. I had the intuition that the things that the psychologists had found in about 1998, Greenveld et al. Had discovered that it's easier to push a button. Okay, if you only have 2 buttons and you have to combine 2 concepts together, if the button has to represent both women's names and family words, or the other button is men's names and career words, that's easier. You're faster to push the buttons than if it's the other way around. In a fair world, if it didn't matter if you're a man or a woman, then it would be equally fast to push both of these. And so on some level, you can think of this as a measure of sexism, but this is implicit bias. This is not what you really think. It's if you ask somebody or if you look at how they behave, they could be more or less sexist than what this implicit measure gives them, okay? So this is actually more controversial than I had realized. The numbers on the bottom there actually show that this is one of the biggest effects in psychology. The D there means that it's more than 1 standard deviation from the average. And I'm sorry, it's a law school, so I shouldn't go into that, but I'll show you a little better than that before. So that was the original findings by Greenveld et al. In fact, that's a later paper by Banagi et al. And then our findings were even with a very small number of words, making those kinds of vectors that you saw, that we were also getting very significant results. Okay, so that sounds like that's news, right? Artificial intelligence is biased, and you've probably heard that. We actually sort of knew that before, but what was new was that the bias came from the people through the text that they wrote on the internet, okay? But it's not only that. One of my co-authors, Arvind Narayanan, was up for tenure. So he was a little nervous, and he said, look, I want to check that this is really working. I want to check it against something in the real world that I know is true. And so I don't think he entirely realized what he was doing, because he just thought it was a check of the code. But what we wound up doing is a consequence. Now, what's happening here is that the y-axis, the up and down axis, those are the reports of these sexist word embeddings, right? These vectors we're talking about. And the dots there are each the name of a job, okay, in the US labor statistics. So some of these blue ones down here, one of those is programmer, okay? And one of the red ones right there up in the corner, that's nurse, okay? So what you're seeing is a 90% correlation between the bias that was in not only the AI, but remember in the people, right? The psychologists had already shown the people had this bias, and the actual bias that's in our society, right? So Arvind was trying to test our code, but what we wound up doing was explaining where implicit bias came from. It was from our lived experience, which is, actually what quite a lot of conservative people had been saying from the beginning. You guys are trying to change the world. And we're like, ooh, now we have to write this paper. What do we say? And what we wound up saying, yeah, first of all, so we're reflecting reality. Our implicit behavior is not our ideal behavior. The whole point of having an explicit mind, right? Consciousness and things like that is to do planning, right? Planning and communication. So we negotiate between each other to come up with the ideals. And that's still important, right? So and we can all argue about what the ideals should be, but that's the point. What we can argue about is how we pick the ideals. All right. So I don't know if it was clear from all that, but this is one of the points. Intelligence is hard. And when a computer scientist tells you something is hard, they mean it takes a long time. Some things are impossible. Some things are only hard. Like it might take longer than the universe is old. Okay, that's only hard. Okay. So speaking of hard things, have you figured out what this picture is? I'm sorry, I keep giving you guys natural science courses. I respect the law, really. All right. I'll go ahead and put it. I wouldn't expect you to know which planet, but this is a planet. See the difference in time in dates? It's a planet going in retrograde. So for thousands of years, astronomers that worked for royalty were trying to be able to plan, and they could predict when these bright stars were going to go backwards in the sky. And that was seen as really a source of power and prestige and things that you could predict it. It was a huge amount of work. And then someone came up with a simpler model. And suddenly that computation was much easier. Okay. So the idea here is that how you model something affects how easy it is to do something, but there's always a cost. Okay. So the perfect model of the universe, I mean, Copernicus is not perfect either. It's perfect circles, which is not the way our galaxy works, right? A perfect model of the universe would be exactly the extent and detail of the universe, right? And so as a consequence of this, we know that all models must be imperfect. And that's why there are bias. There will always be bias. Hopefully the bias that's there is something that's useful and not harmful, right? We try to pick things that we can use. So abstraction is a necessary part of being intelligent. Okay, I mentioned all this partly because I want to talk about what is intelligence. And this is an idea that you don't see very often. One of the points of intelligence is doing the right thing at the right time. And as such, what is the right thing? Well, it differs depending on what you're trying to do. Are you a tree? Are you an ant? Are you a person? Are you a robot? If you are a robot, what kind of robot? What were you built for? What is your goal? So every intelligence is mapping from a context, taking the context and computing the appropriate action to do there. All right. And let's see. So first of all, you can think about it as if we each have some of those local compressed biased towards solving our own goals kinds of maps in our heads. And then the other thing is that even so, it is still a computational action. It is a physical action that takes time, space, and energy to execute and be intelligent, right? Okay. I have the feeling that was unnecessarily complicated because I tried to compress the slides too. But I wanted to add in something about generative AI because I know everybody's thinking about this. So let me give you another view into generative AI, and that will help you understand also where the mistakes come from, okay? So this is a picture of data, looking down from the top on two-dimensional data. Normally speaking, I use the word normal, there's something called a normal curve, right? So most of the data is going to fall in the center, and then it spreads out in a diminishing way, right? So things that happen all the time that are common, that are frequent, are going to be in the middle, and then you have some stuff going out to the fringe, okay? So we can use this, we can project this into two dimensions like this, and then which dimensions are they? Well, let's say that now we're not doing words anymore, we're doing phrases. So we can think about something like left-right as an axis, or we might think about autocratic versus libertarian as an axis. And then even so, even if you can keep, you kind of want to keep people towards the middle because you're more likely to be right there. You have more data in the middle. But even in the middle where it's very well predicted what people might say, there are some things you don't want to hear. Unfortunately, some people consistently and routinely say rude things or are bad to their partners or things like this. And so for the large language model, not only do we take the baseline data, but we also add on another level, which is called the guardrails, that try to steer the model into a part of the space where there's not as bad of things. Okay, I don't know if that made sense to you. Yesterday, I was talking to the students, and some of them were worried about consciousness. And if you ask a large language model, unless it's very carefully trained, if you ask it questions about consciousness, it sounds like a person. That's because it always sounds like a person. The whole point is it's predicting what a person would say next, and we know that because we have all the texts that people write, okay? So if you trained a large language model on an encyclopedia, it would never say I, okay? It only knows to say I because you've trained it on blogs, and blogs quite often have the word I in them, okay? So for example, that maybe in the entire history of the internet, 3 people have said, I'm not sentient, right? That's a sentence. And so you might hope that the large language model would make that prediction, but no, you don't want it to predict things that people hardly ever say because a lot of those are false. So that's why you're not going to see that very often. However, if you have something, and we had this happen a few months ago, where somebody says, I want to move all the conversation over to the side. I want to move it along one of these axes. So you put some more guardrails out there. Now you're out in that fringe that we were trying to avoid before, right? And so unfortunately for not Tesla, but for Grok, right before they were trying to get a government contract, which is why they were trying to move to the right, they started talking about Mecha Hitler, which, you know, whoever said that? Not many people would have said that. But now Grok was pushed into the space where it had found that as a prediction, okay? So what I'm trying to explain to you here is that when you see a false statement and you think it's a lie or a hallucination, you're not understanding that this is just a prediction machine. It's like a library. It's showing you averages over certain parts of the space that someone has decided is probably a safe part of the space, but they can't really control that, okay? So if you see something that's not right, it's probably because you're predicting off of a part of the space where there's not enough data. Does that make sense? You kind of see what's going on there? Okay. Building that first part, the blue part, that's the thing that takes months and months and all the water and all the electricity and the things you've been reading about with the data centers, right? That is hugely computationally expensive to make those generalizations over so much data. And then building the guardrails is the thing that they're hiring people to do. I mean, in theory, you could do that with explainable AI, but in practice, people go and find people that they pay not very much money to just tell the computer right, wrong, and try to sort of beat it into submission. That's the second, and so it's a second layer that you go through. So those are the two components of the typical large language models. Okay, so I mentioned before that words may mean more or less how they're used. Now we can start talking about intelligence and superintelligence and things like that, okay? One of the things I learned as a first-year undergraduate was don't argue about meaning. Just pick one of the many definitions that are out there. You realize that they are going to mean how it's used. So here's a whole bunch of definitions of intelligence, and I'm going to choose number 2. Why? Because it's one that applies to animals. And so language wasn't necessary. We can talk about all kinds of intelligence because a lot of the harms that are done with artificial intelligence are done in things like spreadsheets, you know, with predictions about whether you should get a loan, things like that. So I'm going to choose number 2. There's another reason I like it. It's because it's the definition I first learned, both at Chicago as a behavioral sciences major and also at Edinburgh as a master's in AI, right? So it's a very, very common definition. People sometimes accuse me of having pushed a very weird definition on the EU and on the OECD, but really this is one of the oldest definitions that didn't use language. The book is actually from when they first started trying to think about the evolution of intelligence after Darwin had published the idea of evolution. And they started asking the questions about how animals thought. Okay, so intelligence, as I mentioned, it's the subset of computation, which is a physical process. It's a physical process there. So it's a subset of computation that transforms information about a context into an action, or at least the plan for an action. Sometimes you ask an AI system to give you a plan and you choose whether or not to do it. Okay. And then I think the most interesting thing, as you might have seen in the abstract, is the fact that artificial intelligence has been built as an intentional action, right? Even if you didn't exactly want your robot to ever say Mecha Hitler, you still chose where you put the guardrails and which data you trained it with and how much testing you did before you released it. So it is still the responsibility of someone that they have produced an AI that has said something objectionable, okay? All right, so that's where I'm going to start out. Now I'm going to go a little faster. So a lot of people, if you say that's all there is to intelligence, they're like, no, there's something more. I think there's something agency. Agency is what I mean. And there's lots of definitions of agency. If you're the philosopher Donald Davidson, agency is everything. It's absolutely what it means to be a responsible adult. But on the other hand, there's a simpler definition of agent, which means something that can change its environment, like chemical agents, when there's a chemical reaction. I think to make a very long, potentially long story short, the technical terms for what we really care about are moral agency. So it's not just that you're changing the world, but that you're responsible for the changes you make. And this is something humans have to care about a great deal. However, we don't all agree about what a moral agent is. Different societies decide you're an adult at different stages. Some societies, you don't become really an adult until your father dies. And that means that you probably have to be male to be an adult, right? Other societies, like in Britain, you're an adult when you're 18, okay? So how old do you have to be become an adult? It's just one of the many things. How old do you have to be allowed to drive, to drink, anything, to get married? And then there's another thing we care a lot about, which is moral patience. So what is it that we are responsible towards? What are the things we have to take care of? And again, there is some variation about this. Pretty much every society thinks you need to care about, for example, babies, right? But it was relatively recently that we thought that you have to take care about the environment, for example, right? So there's debates about even whether you can be a moral patient if you're not a moral agent, right? So the environment is not a moral agent. So the moral patiency, so people who believe that you have to be a moral agent believe that the moral patience in the environment is inherited by the fact that it supports the moral agents. So we're really trying to help the other moral agents. Okay, so I think this is what we really care about. And if we understood that, then we would get less hung up on things like intelligence and consciousness and these pieces. We can come down and say, what role does intelligence and consciousness and whatever else, uniqueness, suffering, things like this, have to play in this? But I would argue further that given that both of these things are defined differently by societies, that this tells us a lot about ethics. So again, there are people who feel very strongly, for example, in Islamic ethics, there can be only one ethics. But quite a lot of people now talk about the idea that different societies have different ethics. And this is actually something, we talked about this in the law classes before, that has made the AI ethics migrate away from simple ethics and go towards human rights law instead, because it's something that there's a more general understanding of. Okay. So I would argue that responsibility, so the other things you could look up, those are all dictionary definitions that I've just chosen one of, but this is weird. Now you're getting into my research. I would argue that responsibility is the property of moral agents, right? A society is defined by a set of people who have obligations to each other, right? That is basically what it is to be a moral agent, is to have responsibility. And that in order to really have a society, you have to have enough of a peer relationship that you can enforce your expectations, the responsibility on the other members of your society, okay? So a lot of people talk about trusting AI. I would argue that AI is not the kind of thing you trust, right? It's built, it can be hacked as cybersecurity. Trust is a relationship between peers. So we trust someone if we aren't trying to totally control what they do. And that's partly because, well, it's expensive to try to totally control what they do, right? So at some point you want to trust your children. You know for a long time you cannot trust them. They don't know what they're doing, but they get to a certain age and you think, okay, I'm going to let the kid go, right? I'm going to let the kid stay up all night or something, go to the store, whatever. So again, trust is a relationship between peers, and accountability is our capacity to trace responsibility. And then transparency is how we implement accountability, right? Again, this is a point of confusion. Obviously, transparency is a good, but how much of it you really want, transparency, too much information can be used to confuse people. The right amount of transparency is the amount that it takes to hold people accountable and to keep progressing society. All right. But most of the focus of this talk, coming back to this question of what we're going to do about superintelligence, has to do with this. It doesn't make sense for us to trust powerful agencies. Rather, what we have to do is construct some kind of peer arrangement to hold them accountable. So for example, if we have a very powerful corporation, we might want a government to hold it to account. And if we have a very powerful government, we might hope that our corporations help us hold the government to account, right? So there's means, or in the international community, the states sort of try to hold each other to account, right? All right, so that was all vocabulary, and I'm only halfway through my time already, so I should go a little faster. This is I can't believe that 2023 is old, but it was incredibly quickly done after the release of ChatGPT. And there are newer papers and they show approximately the same things. So I think I'm happy to keep using this one paper. So Noi and Zhang were PhD students at MIT, and what they did, it was very clever. They found advertising, people that worked in advertising, so they wrote for a living, and then they gave them ChatGPT to see if it improved what they did. And how did they judge whether it was improved? They paid the people who mark student applications, the standardized testing in the United States to go to college, okay? So they ranked all the writers, then they gave them ChatGPT. And on average, it increased their productivity by 40%. Now that's a lot, that's great. But it's not the kind of total game change that people had sort of talked about beforehand. but it's a huge efficiency, of course. However, if you look a little bit, that was the headline result, right? But let's look at how it works. How it works is that the bottom sort of 3/4 were brought closer to the 80th percentile. All right. The top 20% of writers, they thought it was fun at first, but they eventually realized it wasn't helping them. So remember, if you're in the top 20%, you're in the top percentiles, you're out there on the fringes of the cloud, and you can't do as well because you're getting pushed back towards average with your writing. So I always try to tell students it's important to learn your own voice, to write yourself, because the whole reason you're at university is we expect that you're exceptional, right? So you want to get past the 80 percentile. All right. There was also relatively recently a project that looked at these enterprise AI things that have been brought into firms. And the weird thing there was that only 5% of firms are seeing returns on $30 billion worth of investment. Okay. So that seems to be something about the fact that they were looking at enterprise, because a lot of people feel like they're much more efficient. And I've certainly heard about certain tasks that people have gotten much more efficient at, including I've just seen with programming can go much faster in certain kinds of areas. But again, usually only by real experts that they are able to use to control and to solve the problems with it. So that's kind of where we are right now using generative AI. If I did write AI software that doubled how good teachers were, what would that mean? Well, it could mean that we have twice as good of schools, or it could mean that we have half as many teachers, right? Or anything in between. This isn't a fact about AI. This is a policy choice that a society has to make. All right. And this is relevant because if you want to talk, people ask me, well, what happens with all this new intelligence in Germany, but not the US. There's different studies there. But in Germany, what's been found is that the same firms that invest in bringing artificial intelligence in also invest in retraining their employees. Okay. Now that's because in Germany, we have very strong labor laws that go back to 1918 when people were worried about a German-Russian revolution. Right. So they're very well represented. Now this is on average. On average, the employees actually wound up with more interesting jobs and better salaries. But again, it wasn't everyone. So about 10 to 15% of workers were left employment. They didn't get re-educated. And unfortunately, it seems to just be the ones that are over 55. Okay. And we're not even sure if it's the workers themselves or the company that didn't feel like going through the retraining at that stage of life. But it was not whether they were college educated, which really surprised the authors. I would do another puzzle here, but I'm running short on time and you guys didn't guess the last one. Well, I will. This is supposed to have been, when the paper was written, the guy thought that he was writing a paper about exposure to, so RTIs, these routine tasks that we expect that robots can take, right? And he was showing how important unions are, which is true, to keeping your wages up. But does anyone think there's something strange about this graph? I'll tell you very quickly. I said, why, when I first saw this graph, I said, why, if it's about artificial intelligence, why is it all happening between 1985 and 1995? And he said, well, we economists think there hasn't been much happening in AI since the year 2000. Okay, this is in 2021, so just before ChatGPT came out. But everyone in AI knew that the AI had gone through the roof since 2007. 2006 was a huge breakthrough in deep learning. And 2007 was all the data we got from smartphones. So everything changed around 2007. What this actually is it's American data, and it's when China entered the World Trade Organization. So suddenly there were people who could do these jobs, and people did reduce the wages. I didn't keep these graphs in because, and I'm certainly slightly diverging from superintelligence here, but in fact, in the history of automation, normally you increase the number of employees because you make a process more efficient, it becomes more affordable. And so as you automate, You keep increasing the number of employees up until you satiate the market with the demand. And then you have a gradual decline in employees. But if you suddenly have a whole bunch of humans that can do the same thing for less money, then wages come down. And again, if we look at the same paper by Battisti et al., in Germany, the same thing happened 5 years later because the wall came down. Suddenly they had access to East Germans and a lot of other East Europeans who would take lower wages and even spoke the same language. Okay. When you have lower wages, in general, you're going to wind up with higher inequality, especially if it's only the lower wages of the people doing routine tasks. And the last time we've seen this high of inequality and this high of political polarization was basically the period right up before World War I. Okay. So it seems like when there's a new technology that reduces the cost of distance, it becomes easier to create a new company and to get a whole lot of power into one person, right? So in the late 19th century, that was railways and oil and telegraphs and newspapers. Now it's a lot of internet businesses. In most countries, I've heard not Germany or China, and that makes sense to me, but I have not found that paper. So if you guys know the paper, let me know. We've known this correlation to exist for decades, but nobody could explain it. I think I have an explanation, which is basically that if inequality is going up faster than the economy is going up, then for everybody else, it's going into decline for the majority of people except for the elite. And if the economy is going down and you can't pay your basic requirements like your rent or your mortgage, then you become risk averse. And that's when you become effectively polarized. So we have data on this. It's very cool, but that's not what this talk is about. What I'm going to focus on here is just that we were able to fix it the last time. So after World War I and after the crash of 1928, enough of the elite in the two richest countries were willing to join with the proletariat, basically, that they were able to then to increase redistribution and reduce inequality. And then after World War II, this was brought to the whole world. So through the Bretton Woods Agreement, for example, we've forced people not to do more redistribution and not to do this wealth extraction that makes it easy to create inequality. Unfortunately, we seem to have lost motivation to do that around 1978. And you can read things about what happened to Bretton Woods and whatnot. My own theory, again, which is you can find in some of the other the polarization papers I mentioned, is it might be that was the time when the Soviet economy plateaued. And so, again, the elite no longer saw a reason to do redistribution. So that's my suspicion about what happened in the OECD. Let's talk a little bit briefly about artificial general intelligence. This is my own picture taken in Paris this spring. And right after this picture, Sam Altman sits down on the stage, and the woman there, I've forgotten her name, I'm sorry, asks him, what is artificial general intelligence? And even though we all know he gets a huge payout when if he achieves AGI, he said, it's become evident that nobody knows what it means, and it probably doesn't mean anything at all. Okay. So I'm kind of dismissive of the whole concept of artificial general intelligence. But the basic idea is when AI meets or exceeds human abilities, then we've achieved AGI. But the thing is, we already have that for all kinds of applications, chess, Go, speech transcription, lip reading, deception detection. We've had this for decades. And we've also had things like books that could remember things forever, and planes that could fly in the sky, and buildings that can keep us all dry, right? Being superhuman doesn't make you a kind of a human, that has human desires, human goals, human phenomenology. So a lot of the incredible growth in AI, as I was just explaining to you, it's because developers have figured out how to use machine learning to upload the previous computation we've done. Remember I told you how expensive that is? It's less expensive if you can upload the work other people have done. All right. And that's also our magic power as humans. Language allows us to communicate what we've figured out in our head. And so that's part of the reason that we're just totally dominating the ecosystem, maybe a little too much, right? But I just want to show you this graph that people usually take to say, oh, look how scary it is. We're going faster and faster. Well, first of all, this is nonsense because we were doing reading comprehension in the 1960s. So I don't know why they choose to make the line look straight there. We were trying to do it. It is true, we do it much better now. So the ends of the line are good, but the beginnings don't make sense. Same for language understanding. That was the first thing they funded for artificial intelligence. Americans don't trust Russians. And so they wanted to know what the Russians were writing, but anybody who could read Russian, they didn't trust. So they wanted machines to read Russian. And that was what funded a lot of AI research in the 50s and 60s and 70s. So anyway, we've been doing this stuff much longer than this, but look at what happens. You're going up and then you plateau just over human performance. Why? Because what does this kind of thing even mean if it isn't human performance? Maybe image recognition could go past human performance. But as I said, the way we're getting good at it is by using human knowledge. So it's unlikely we're going to go much beyond human performance with human knowledge data, right? Although, of course, I suppose this is what they're trying to do. I just want to show you something about predictions. So this is the predictions of the British government about how the British economy is going to go. The white lines are going up are the predictions. The blue line is the fact, okay? And you might notice that not only does it go up a lot slower than is predicted, but also it's gone down since Brexit, all right? On the contrast, this is what Western economists keep predicting about how much solar power we're going to get, all right? And it goes up much faster than we predict, right? Why would that be? I think the predictions are based on an infrastructure that wants petrochemical to be the right answer and doesn't want to know that solar can be this good, right? So beware when you see systematic prediction failures. People have thought that AI was going to become a person ever since I was born, right? Since the 1960s, right? So, and in particular, realize that there are some very good documentations of some scientists being paid to believe things, right? So you have to be careful of that. All right, so let's talk about superintelligence. We'll get a little more fun now. I'll skip over this. This is just about the singularity, which is something people talk about a lot. So here's the coming technological singularity from Werner Vinge. He was a science fiction writer. And in 1993, he started going around saying, I can't do my job anymore because I'm a hardcore science fiction writer. I want to write the truth. And there's this moment coming in only 30 years where AI will be superhuman and then the human era will end. And I can't predict past then, okay? So that this is a different idea than AGI. I say here that it's the same, but really superintelligence is different, but it is the same as intelligence explosion. So some randos talk about this now, but the first person to talk about it was I.J. Good in the year I was born. And he basically said, this will be our last, sorry, I forgot that guy's coming up. He said, this will be our last invention. That's cool. He thought it was great because when you have a machine that can learn how to learn, then you're going to have exponential increase of intelligence, and then the machines will do all the work, and that'll be great. So Nick Bostrom was working on funding his nice center at Oxford, and he wrote a book about superintelligence and said, no, this is bad, right? We don't want to have things smarter than us. Again, we've had calculators that could do math better than us, and they don't even take over our pockets, right? But anyway, he was, no, this is bad. But he was a good philosopher, even if I don't agree with some of his understanding of social science. And he did the math and he said, look, if you have exponential growth, if you think about that, not only is that a consequence of learning to learn, but another thing is that even if you could keep your machine to do the things you wanted it to do, it might do something like it might solve that problem if you let it go in a way that you don't like. So his famous example is that you say, please organize my office, and somehow the machine turns the entire world into paper clips before anybody unplugs it. Okay, I promise you that everybody has kill switches on their AI now, almost everybody. I shouldn't say that. Actually, be very careful about cybersecurity. A lot of people do random things. But anyway, let's focus on this exponential and exponential growth. Like I said, I do believe in superintelligence. And here's why. Okay, if you accept that intelligence can, and this is not what I told you before, but if you can accept that intelligence decomposes into all the parts of what I previously said was intelligence, right? So the action part, the perception part, the motivation, the memory, the learning, the reasoning. I want to focus particularly on the memory. Then absolutely every machine we've ever built is a form of AI. They're all extending our intelligence, right? They all allow us to do things we haven't done before. And in particular, if you think about writing, right? Writing is something that totally super enhances our memory. All right. So let's say that there's been 12,000 years of AI. Then the intelligence explosion is us. And here you go. So sorry, it's another graph. But the y-axis there, the y-axis here is the number of people in millions, right? And it's on an exponential. So you have an exponential curve on an exponential scale. Incidentally, that dip down there was a plague that hit China, if you're wondering. But mostly it's an exponential up. 10,000 years ago, that's not very long in the history of biology, right? In the history of the world. There were more macaques than there were humans, hominids, right? But now look where we are. Okay. All right. So this is the title I wanted to have for my book, but it doesn't turn out to work very well. This is another look at an exponential at the bottom, and then it kind of flips over on the top. And so that's called a sigmoid. And that there, I was saying, well, maybe the singularity happened 10,000 years ago. And we're at this point, the orange there is showing you how fast change is. We're at a point where there's really fast change now, but maybe it's going to slow down and we're going to level out again because we've kind of, we've taken the maximal advantage of our special abilities. And now we're just going to figure out the sustainable development goals and settle everything back down again. All right. Mathematically, there's only one inflection, but it doesn't matter very much. All right. So let's go back to these unanticipated consequences. If I'm right that we're on exponential growth, if we are the superintelligence, is there anything unanticipated? Well, one thing is that I don't think we all expected to wipe out all the other animals. That wasn't our goal, right? It's just a side effect. So we're taking all the biomass in fossil fuels and we're making more biomass, but fewer species. So this is a nice drawing from XKCD, in case you don't like to read graphs. The dark gray is how many land mammals are humans. The light gray is stuff we eat and play with. And the green is the wild animals that are left. Okay. So that's a pretty scary chart, and those numbers are from the knots. It is really a big deal to try to save some rewild or whatever places to keep some species. But I do want to say, yeah, so we're the paper clips. Sorry, I forgot about that build. I'm going to skip these two. The basic, oh yeah, but what I do want to say is that don't forget life is not zero sum. Right? There used to be rocks, and now there's more and more and more biomass, although it's fewer species. We're focusing the species maybe a little too much, but don't forget that life is productive. So there are ways to solve this. So this is a very different graph where you see, yes, there's been a terrible reduction of the wild animals, but not as terrible as that graph looked. The main thing is we've figured out how to keep a lot of people and a lot of cows alive, and pigs and chickens. I've been a little while here. Okay. This is another graph, which is going to become relevant later in the talk, if I still have time. But to show you a similar thing here, the United States economy keeps going up, but its influence in the world goes down because the rest of the world becomes more fair, right? It's the success of the liberal project that people's lives are starting to become productive everywhere. Right? Of course, some places more than others. But so just realize that sometimes when you see these percentages, it looks like someone's winning or losing, but actually it could be that everybody's winning. Some people are just sped up their winning a little bit, right? So governing AI from the European Union's approach, I have to say, this is Eric Schmidt, and he literally on a live, again, COVID telephone call said to the German leaders, and I happened to be in the call, too bad you don't have your own AI to regulate, right? The AI Act is coming out in 2023, right? But so I immediately started typing in the chat, which there was. Fortunately, they left it on so the German government could be arguing with him, and I argued instead. Look, West Coast artificial intelligence is produced by people from all over the world. It's like the gold rush. They move there, right? And secondly, it uses data from people all over the world who often haven't consented. So I would argue that this is not really just US AI. This is global AI, right? Everybody who's contributing to the data and contributing to the employee pool. Secondly, and I didn't say this to Eric Schmidt, but this is just a fact. Every state that has signed the Universal Declaration of Human Rights, that means every state, is obliged to proactively defend the human rights of every human within their borders. And that's the main thing that the digital governance of the EU does. Okay, but let's just look at this claim a little bit first before I go into that. So this is a graph that was circulating on Twitter a lot. And you see, and I didn't know that much about competition law, but I knew that big companies indicated that people weren't doing a good job on antitrust, right? On market competition. So I'm like, why do you only count the biggest companies? Why can't we find out all the companies that are building AI? I bet the EU would be doing better. How did I guess that? Because the GDP of the EU was like 20% of the world's GDP at that time. And AI was everywhere. So there was no way we weren't doing AI. Okay. All right. So yeah, this is lies. Don't take a picture of that slide. Right. So it focuses on the largest companies. So the underregulated jurisdictions look better than they are. Did you notice that Samsung is in the thing that it says China on the top, underneath it says Asia, but somebody has labeled that China, right? To make it look like Europe has, the whole argument made no sense. They're saying like, look, if Europe, you don't matter at all, so you have to side with America or else China wins. What? If we don't matter at all, who cares who we side with, right? Anyway, it's all lies. Okay, here's the data. So in collaboration with Helena Malikova from the Director General of Competition, funnily enough, of the European Union, we were sitting next to each other when that slide came up at a conference once. She looked at every single patent. So she chose the WIPO database. You probably know this. Now we're in the law domain, right? The WIPO database is global. So it's a way to let us compare all the countries. And so she looked at every company that was defending at least 2 patents in the WIPO database in 2019 in that particular category. It's not all the AI, but it's a good random sample of it. And then she looked at the market cap of those companies holding that. Okay, so we've still got the circles because people love the circles, but we again have log on the axes here. You notice that both Germany and China have strange companies that hold a lot of IP but have no market capital, that have nonsensically been put on an axis there. But that's because the patents seemed important to us. Okay, so in case you don't have magic eyeballs that can do sums, the EEA, the area covered by the digital governance of the Europe, which is slightly larger than the EU, is not that different from China. But while we were busy showing that, we accidentally showed that the rest of the world, excluding the United States, was more important than Europe and China combined. Okay. And which is, again, that's about 40% of the world's GDP. So it's not surprising that it's about as important as the other 40%, right? And then the US was bigger than both of these. But what I used to say when this paper first came out was, but the US has a lot of influence both on patent markets and on market capitalization. So I'm not sure if those numbers are really, why is the US so far out of line? Okay, so this is published, you can look it up. Now I'm going to show you some secret stuff that we haven't put out yet. It's not even on archive, sorry. Done by some of my master's students. So this is actually going back, so this is Wiebke Dorf's master's degree. That's why she's the biggest one down there. She's now working in the German government on AI policy. Anyway, so she went back and looked at those 2 years that we had looked at more carefully. She looked at every patent. And then you could see that the EU was already comparable. This is just patents now, with China by 2019. Also notice that she broke out Japan separately. Japan was accounting for a whole lot of the patenting. Okay. Then we put out our paper, and I'm not trying to be megalomaniac or something, but I literally had weird random people like JP Morgan come up and say, we were really angry not to be on that graph. I mean, who cares? It was just like a random sample, right? But they cared. Okay. So this is what happens. After our paper came out, maybe by coincidence, China and Japan went nuts putting patents into that particular WIPO thing. Okay. And so they're actually exceeding American numbers there. Well, not entirely, but they're comparable. And you can see the EU is doing relatively steady progress on this too. But here's the market capitalization. And again, you see that the EU is comparable to China. To be honest, a lot of the market capitalization of the yellow part is Saudi Aramco. That tends to have like 1 or 2 patents in AI every year, but it's mostly oil that's driving up the market cap. But you can see that Japan's massive patenting is not entirely reflected. It's not as big of a difference as that we saw in the patents, but it's still a pretty respectable part of all the market capitalization going on. Okay. Incidentally, notice that we just gave up and cut off the US. It's just gone through the roof since 2020. And everybody is asking, is this real or is it not, right? The interesting thing is that it turns out that if you don't have those top 6 companies, the US economy has done what it almost never does. That's why I showed you that graph. It's going down. Okay. So this is another graph from Helena Malikova showing that the median was basically flat on this S&P 500. It's just the top that's pulling it up. Okay, so what is the EU doing about all this? Originally, we did the General Data Protection Regulation, which actually was, again, I have students, I don't have time. In fact, you saw briefly Vivo, that has shown that it lowered the costs for companies. They increased their profitability in at least German companies after the introduction of the GDPR, small and medium-sized companies. Why? Because it harmonized all the existing data protection rules between the 28 countries at that time of the EU. But coming back to this thing about protecting citizens and residents, right? I think of what AI does to data as being like what airplanes did to airspace. You didn't used to even talk about airspace until people could fly over you and drop bombs on you. And you didn't have to worry about personal data so much before people had ways to use artificial intelligence and figure things out about you, right? So the Digital Services Act is basically a way by which we make sure that GDPR is being observed and the things that we saw do a lot of harms around elections, like Brexit, like the first Trump election. So we're checking on recommenders, targeted advertising. In theory, the companies, if they want to be able to do things with the EU, they have to show us the logs so we can see what's going on. And they have sort of that it's, how much we're enforcing is an issue. And of course, something Trump and Musk got very excited about this act belatedly. They all thought the AI Act was the big deal. It wasn't. I think it was like a decoy. Okay. Speaking of the decoy, the main thing it does is make sure, well, it bans certain technologies, like you don't want people to biometric sensing to track people everywhere. But mostly it says that if something is going to potentially change somebody's life, then you have to keep enough records that we can tell if you've done due diligence. Okay, and then finally, the only one there's actually about 20, but I'm only going to talk about the 4. There's something called the Digital Markets Act, and this is huge. And it's weird because we just had something last week in Berlin called the Digital Sovereignty Summit, and everyone was talking about the Digital Markets Act. So this is where we're trying to keep the companies to a size that we can govern them. because the country that innovated antitrust law has stopped doing that. They switched to national champions model again. And just as was at the end of World War II, the US and the UK forced Germany and Japan to put antitrust into their new constitutions and also to break up their biggest companies. They said, look, if you have too big of a company, then either it takes over your government or the government takes over it. And either way, you get autocracy. What's happening to America now that they stopped breaking up companies? Yeah. So anyway, I'll quickly say about the Brussels effect. You can think of the EU as a constructed peer. That wasn't really what they were trying to do at first. They were mostly trying not to kill each other, right? But they wound up, because that was a really strong motivation, producing a unified actor. And they're not really trying to police the world's AI. They only are trying to police their citizens' well-being. However, it's really expensive to write legislation. And so a lot of the world that doesn't have that much money is trying to copy and paste some of the legislation from the EU, which does not always work if they don't have the same enforcement capacities. But I think the main lesson of the Brussels effect is this. Any economy can ask for compliance costs proportionate to the value of their market, okay? And so that's what we need to do. We need to harmonize our compliance asks, even if we're not in the EU, or even if we are. Okay, so I know I've run over a little, but I only have a few slides on this. Should everyone join the EU? Probably not. I don't think that's the solution. There's two reasons. I think we were talking about this a lot yesterday evening. I think diversity is absolutely essential for avoiding regulatory capture. I mean, Kant said that hundreds of years ago. He was a pretty smart guy. Secondly, different states have different capacities, as I mentioned before, priorities, resources, neighbors, threats. And so, of course, they have different legislation priorities. But maybe what we want is that any country, this turns out to be pretty much every country, except for 2 or 3, that they might want to find neighbors that they can, or like-minded people that they can put their regulatory asks and pool their regulatory asks with. So maybe that's a good idea. So at the AI Action Summit, which was supposedly global and was run by the French and the Indians in February, I already showed you Sam from the second day at the Business Summit, but this was the main stage. It was basically global agreement. It was just amazing because, you know, Trump and Musk, I thought they were going to be subtle about the conversion of America, but they were not being subtle, right? So people were just shocked by what was happening in America. And then also DeepSeek, I'm pretty sure China must have coordinated that because we knew they had great LLMs, but they also had big issues with the guardrails, right? About what you could and couldn't say. Because of course, again, if you look at the internet, you find a lot of information. So anyway, I think those two things combined helped open people's minds, but also the French have been working on this for a year. I don't know as much about the Indians, but I ran into people that were working on this in the French thing. Every stage was talking about the need to reduce market concentration. Ironically, they called that diversity because Trump had just said that diversity is a bad word. And so they were constantly saying diversity, but they didn't mean either ethnic nor gender. They meant just providers, okay? They also were all talking about sovereignty and plurality, that you have to have, it's not only about market concentration, it's about resilience that comes from the fact that you have multiple threats, as we learned during COVID. And they were talking about the role of nations as regulators. So this was actually the third of a series. The first one was being run by the UK, by their conservative government, and Elon Musk was like owning Rishi Sunak. I don't know if you remember seeing the interview, but it was just insane, right? They were just almost, you know, saying, yes, the AI, it should be safe. And please, can you make safe AI, right? In this one, we were not saying that. We were saying the government should be doing this. I mean, I wasn't on this stage. I was on the stage of the business day, but not this one. Recognizing AI without cybersecurity is useless. It was fantastic to hear people thinking about security. I guess having a war with Russia helps you think a little more about cybersecurity. And recognition of non-supersized US AI, that it was AI. Literally, people before that didn't think it was AI if it wasn't coming out of Google or Microsoft. And suddenly there was all these, as there always are, all these stalls of people with their AI, and people going, oh, look, that does work, that does work. And I think that was DeepSeek more than Trump. I think that DeepSeek kind of made people realize you can do AI and not have to be huge. So I think this is a weird metaphor. Again, this is, sorry, physical sciences. But the idea is that the thing that holds a molecule together is sometimes shared electrons between them. And so again, I don't think that there's like Brussels is so special. I think there's a bunch of centers. Russia is definitely a center of weight. China, of course, you know, India, the United States. And there's some places that will always be between them. Okay, historically, the UK was one of those centers. Now it's basically suspended between the EU and the US, right? Ukraine is between the EU and Russia, and it always will be. You know, Turkey is between the EU and the Middle East and the Arab world, and it always will be, right? So I think that what we need to think about is putting together an alliance that should be agile, so we don't have veto players like we're seeing right now in the World Trade Organization and the UN Security Conference. And also that we need to figure out, so we don't want to have veto, and if you defect, like the UK chose to do, it has to be costly. The people who defect are the ones who pay the costs. It should be relatively easy to decouple from the main part. And there has to be something that makes it worth government's effort to actually be doing the regulation. So that's obvious because these companies have more money than they can legally spend anyway. They're clearly under-regulated, so that we need more redistribution. I'm here talking about what Macron calls the hyperscalers, right? The vast majority of AI, as I just showed you, is small, normal companies that the market can regulate fine. But we're just talking about these big transnational entities that kind of blow up. I think the reason they blow up is because actually they're utilities. And again, the original antitrust theory said, if something is a utility, if it naturally scales, then it takes extra regulation, not less regulation, okay? So I'm not sure, I don't think it's only a failure of will of the US. I think it's also that the transnational nature of these hyperscalers may be why we need to work together and pool our efforts. I don't think the EU is going to really be able to do it itself, although it's kind of it's a crowbar into this problem. But I think we're going to need to work a lot more between ourselves and come up with some interesting international treaties. So, and then, yeah, the companies have to still want to come in. As I said, you have to give them enough business as a reward for their compliance that it's worth their effort. Otherwise, why wouldn't they? But realize that periods of really high inequality like this are also super unstable for the elite too. Whoops, I think I'm doing this thing with this. I talk too much for these microphones. So this is bad for the elite too. They also wind up having very unstable, like if you look at the C-suites, they have much higher turnover in these periods of high inequality. It gets harder to govern as well, right? So it's better for everyone to reduce the inequality a little bit so that you actually have a better chance of maintaining your rank ordering instead of having some random thing happen, okay? Yeah, and as with Airbus and as with, you know, electricity utilities and things, you often decide to go with multiple providers anyway for resilience. But I think maybe this hasn't worked out too well for Germany and Russia. We tried it, but maybe sharing the shared stewardship will help us build stronger alliances. So the possible way forward, as I mentioned, is the electron cloud model, where the world is well represented. At least every country, hopefully, is well represented by some nearby strong nucleus with shared interests. The U.S. wants there to be a single regulatory regime because they want their companies that looks just like its, so the companies can not have to work too hard. I think somewhere between 8 and 20 is a better idea. As I mentioned, diversity benefits innovation, and it also helps us avoid regulatory capture. The nuclei, because they're big enough, negotiate the treaties. And then the other guys are on the edge, which for the EU is like Norway and Sweden, not Sweden, Switzerland. And the UK now just wind up not having a say, but sort of getting their negotiations done for them. Realize this is not only about the big companies you've heard about. Clearview AI is doing all the face recognition for the US, and it's very small, right? Palantir, okay, it's not so small, but still, It's not the kind of thing that cares as much about brand. And so it's not as easy to control, and it doesn't have as much infrastructure. So it's not as easy to control as Google or Microsoft. All right. So maybe we have a global AI regulatory body, but if we do, I think it'll be more like the IAEA. I think that if there's anything for the UN to do, it's to try to help us negotiate these treaties. But then it should be optional, opt in if you want to be a part of this. And yeah, hopefully we'll use AI well to create transparency and ensure legitimacy. So that's everything I promised to talk about. I talked about 15 minutes too long, I'm sorry. Superintelligence is everybody's problem, and we all compose it. We are the problem. We are the superintelligence. AI is an extension of our culture and machinery that lets us extend our culture even faster, right? More compute, more energy. The problems of regulating AI are continuous with the problems of governance we've already had, with the possible exception of these hyperscalers I was just talking about. So transnational utilities may require a new transnational instruments or treaties for some kind of collective regulation. So that's it. Thank you.